Okay, so in this, okay, so today, as I told you, that today we are going to work on this chapter number 2, which is our
Okay.
STP,
Spanning tree.
RSTP, and MSTP. Okay, so STP is known as Spanning Tree Protocol, RSTP is Rapid Spanning Tree Protocol, and
Yeah.
MSTP is
Multi.
Multi Spanning Tree Protocol. Okay, now,
Okay.
so first in this, we will know about STP, then RSTP, and after that MSTP. So when we
Okay.
are talking about STP, Spanning Tree Protocol, so if you have been using this Cisco switches, okay, so if you have been played or used the some of the Cisco switches before, you might have noticed that every time you plug a cable to the switch, okay, the LED above the interface become orange, and after a while it becomes green,
Green.
right? And we have
Yes.
seen this many times. So if you will see here, so I'm just taking one packet tracer example. So if I have one switch, I have another switch. So whenever I'm trying to connect one switch to another switch,
Okay.
automatically your port will start acting with the some,
Orange.
yeah,
Wait.
orange, some activities are going on, right? Okay, after
Okay.
orange you will see that it will become green. Okay,
Yes.
but if we are talking about some, like computer connectivity, computer to computer connectivity, okay, suppose if I have this computer, I have another computer here. When we are connecting computers, so in computer you will not see that
Okay.
these states are running, right?
Yes.
Okay, but in switches,
Automatically.
yeah, automatically they will come in the up state, but in switches it is running. But which type of process is running behind the switches? So here we are coming to know. Okay, so now here is asking that any idea what is happening between these switches, that why it is coming as red, first orange, and then
Orange.
it will become
Yes.
green, right? Okay,
Okay.
so what is happening at the moment, okay, in this process, that there is a protocol running in the background of all the Cisco switches known as
Yes.
STP, Spanning Tree Protocol. So what that protocol is doing in this process, so you can see here, it is determining that the states of all the switches interface. Okay, so first process is what it determines the state of the port, right? Whether it
Okay.
will be in the blocking state, forwarding state. Okay,
Okay.
and it also verify that you do not have a loop in your switching network. So
Okay.
STP, with the help of STP process, you will have two options. One, switching will give, this STP will give you loop free switching network,
Okay.
and it will also give you the role of your port, the link,
Okay.
that okay, I am this, I am that. Okay, and the role of your switch, that I am root switch, I'm okay, I am root port, I am designated port. So each and every process which is running, okay,
Yes.
through this STP defines all those options what we are talking, like okay, this switch will become root, the port will become root port, designated port. Okay, so these things
Yes.
will be running with the help of STP protocol.
STP.
Now, why we need STP to know? See here, network switches connected with single point of failure. Okay,
Yeah.
and if you have this network, you have switch here, you have switch, you have trunk link, and they are connected, right? So here we don't need to worry about any kind of process, because STP is automation, right? It's automatic process.
Okay.
Okay, Now, but problem will come here as a network administrator. If this link will go down, then you will say that no, 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 let me have another link here, because if this, we cannot rely on a single link, so we can have multiple links, right?
Okay.
Okay, so when you have multiple links, right? Okay, then what will happen? See, I'm talking without STP. Okay,
Okay.
so if you will have multiple links, so if I'm coming here to your this, okay, let me create new file. Okay, okay, this is switch, and now we are talking about, let's take one hub, one hub here and one. Okay, so now see, if we are talking here about this switching network, okay, so if you have single link towards another switch, and you have a network which is connected, right? And if this single link will go down, at that time your whole network will go down, because you have single path to reach to any destination, right?
Yes.
To overcome from those type of problems, you came with alternate link, or you can say redundant links towards the another switch, right?
Yes.
Now, but you can see here one port is in a blocking state, and one port is in opt state, right?
Forward.
Forwarding state.
Yes.
But if you will say that, like, who is blocking this one? STP is blocking, as we know, as a, right?
Yes.
Yes. But for example, like, if you will say that, okay sir, let's think that we do not have STP right now.
Okay.
Okay, for example, if we do not have STP, then see what will be the problem in your network. Then first we have to know the benefit of STP, then we can work out.
Okay.
So my IP is 10.0.0.0.1 here, and here my IP is 10.0.0.0.2. 'Now I'll come here to my PC desktop. I'll configure IP address 10.0.0.0.1, 10.0.0.2. Now everything is okay. Now if I'm coming to my switch, CLI enable so spanning tree, I will see that all my ports which is connected, all is in forwarding
The
state, right?
forward. Yeah.
Forwarding states, no problem. Here if you are coming to this switch, enable so spanning tree, you'll see that
Two
One
is
port,
in forwarding.
yeah, two port is in forwarding, which is connecting to, one is another switch and one is PC and other one is blocking, right? BLK is
Yes.
blocking
Yes.
STP. Who is blocking? As we have already completed CCNA, so we know that STP is blocking it, right?
Yes.
For to stop loops, okay.
Good.
And now if you are coming to simulation, if we are using one packet, send packet from here to here, and if you'll see that the packet is moving, okay, packet came to destination, right?
Yes.
Okay, now you see that this PC is replying,
Okay.
reply will go back and it came to PC, okay.
Okay.
Now if now, okay, now this is now, this is unicast communication, no ARP has completed now. Now this is ICMP packet direct to the PC, right?
Yes.
Okay, now for example, okay, let me make this little bit bigger network.
Okay.
Okay, real time, I have one switch here. Let me have one more switch. Okay, this path, this path, and let's come to another path. So this is also redundant path, right?
Yes.
Okay, so let's, okay, so one link is blocked,
Yes.
okay. And now suppose, let me show you again. If this PC wants to communicate to that PC, see how it is going.
Okay.
See, here packet is block. Why? Just
Yes.
because of block port. Now packet is
Yes.
going, so now packet will be forwarded from this link instead of that block link, right? And it will reach to the
Yes. Yes.
source.
Yeah.
Yes. Okay. And now again, if you are talking about same another communication, now see how it is working. See, again you will see. Okay, now let me show you. Packet came to this switch. Okay,
Okay.
it will forward directly to this switch and then it will come to the destination.
This way.
Okay, no any other kind of forwarding has been done already. Okay,
Yes.
because only one time forwarding is running. After that, see, communication is okay, no problem. Now see, the reply is also direct, right? Unicast.
Yes.
Okay, so now let me come to real time, delete this one. Now I am coming to this switch. See, right now STP is working, but if I will come here, conf t no spanning tree VLAN 1. Now I'm going to stop a spanning tree, okay. And now
Okay.
if you'll try here and if you'll check, so spanning tree, no spanning tree, right?
Yeah.
And why I'm writing this VLAN 1, because by default all ports are in VLAN 1, okay.
Yes.
So I came to this switch, enable conf t paste, so spanning tree, no spanning tree. Let me come here in a conf t, no spanning tree, so spanning tree, no instance. Now you see the ports are green now. Okay.
Yes.
Okay, now see the problem. If I'm coming to simulation to show you the packet movement, okay, and now if I'm taking one packet and now I'm taking from here to here, okay, and now
Okay.
let's play this. Now see, and see, you will see that this, see it, the packet has communicated to destination, right?
Yes.
Okay, but see, still it is in process.
Yes. Keep on
Yeah, keep on
progress.
process, it will not complete. Okay,
Yes.
but if I'm telling, let me come to real time again and see how the broadcast strom is running. Can you see this blinking?
Yes, it's linking.
Yes, but if I will tell you that, okay, no problem, let me come to the switch, conf t, spanning tree, VLAN 1 on this
Okay.
spanning tree here. Now let me come here, conf t, spanning tree, VLAN 1, conf t, spanning tree, VLAN 1. Okay. Okay, so this is your, I don't know who is your root switch. Okay, so this is your root switch. Okay,
Yes.
and others are, okay. So if you will come here to this switch and if you type here, so spanning tree, you will see that this is a root switch, right? Okay, now if this is a root switch and in this situation, if I'm trying to communicate, if I'm taking one packet to source to destination, okay, and if you'll see next forwarded, no problem, first time came, reply, and reply came to the source
Source.
back, and now you can see here it is successful, right?
Yes.
It's successful. And now why is successful? Because packet started from source, came to
Yeah.
destination replied that yes, I'm reachable, right?
Yes.
Okay, but if you will talk about that, okay, no problem, let me come again to the switch, and if you'll say that no spanning tree, VLAN 1, come to this switch, no spanning tree, VLAN 1, and if I'm coming to this switch, no spanning tree, VLAN 1. And now if you're talking, see, okay, now there is no
Okay.
process, but if I'm coming to simulation, now I'm taking one packet from source to destination, and now you will see that source and destination has communicated. Okay, see, the
Okay.
packet came to switch 1, okay, ICMP packet, you can see. Now it came to switch 3, okay,
Yes.
or switch 2, whatever you say, and then it came to destination, right? Now you can say that
Yes.
communication has done. Now this PC will reply also. See, reply came to
Okay.
switch. Now it will be, yes, now came here, okay, and now came to this, right?
Yes.
Okay, okay, saying successful, no problem. Let me take one another packet. I don't know. Okay, now this is a new packet. Now let's see.
Okay.
I should, you know why this is, they are doing like this, because MAC address entry was there. That's why. Okay.
Yeah, yeah. It recognized already the
Yes.
destination address.
Yes.
So at least maybe you have to
But no
reload it.
problem, what I can do, I can delete this process, I can come to switch, and remember what
Okay.
is the command to delete the MAC address. If you check here, so MAC
Yes.
address MAC address table, so it's already there. So what I will do, clear
Yeah.
MAC address
Address
table,
table.
right? Clear
Yes.
this one from here. Let me come here, clear MAC address table in privilege mode. Okay, clear MAC address table. Now we can try, right?
Yes.
Now come to simulation. Now take one packet from source to destination. Now try. See, broadcasted,
Mm-hmm.
and now you will see that that packet will be in process for forever.
Yes.
Came, forwarded, and now you can see I generated single packet, but now you can see how many packets are there in the network. Okay, see how many packets. Can you imagine
Wow.
if there is no
Yes.
STP? Just with this single 2 PC is generating this much of packet. And see, each and everyone is communicating, but still the packet is in process. And it will never stop if you are talking
And they
about
do,
1 day, 1 month, 1 year also.
yep, they do not understand each other. So.
Yes. No, the communication is happening. Okay.
Yes, but keep on
Yeah, the
happening. So.
packet will be in the network. The packet
Yes.
will never discard. Why? Because see, layer 2
Uh,
packets doesn't have TTL value.
okay.
Like suppose if I'm coming here CMD, okay, if I'm telling you ping google.com, see here, the Google has TTL value, right? Means
Yes.
if I'm sending this packet, means after 170 hop, if Google is not replying me, means it
Yes.
that packet will be discard after 117 hop. Okay, so if
Yes.
I'm saying okay, no problem, let me ping to facebook.com. I think this one is a smaller, yes, 57. So till 57 hops my packet will try to reach Facebook. If not, then after 57 hop it will drop. But in layer 2 packets there is no hops. Okay, and it will see the
Okay.
communication is failed, right? But still that packet is moving from source to destination. See,
Yes.
so this is the biggest problem of your uh, layer 2 network without STP.
Yes.
Okay, that's why STP came. And when STP came, STP blocked one interface. Okay, if see, if you have single link, then there is no any problem with the STP. Okay, because one packet will come here, okay, and then communication will occur, no problem. At that time there will be no any kind of loop. But if you have redundant link, so the loop will come from this side and it will come like this.
Okay.
Okay, and why it is working, say here, let me come again to this packet. Let me come to real time, delete this. Let me bring the port, always show port labels. Okay, now see, if any packet is coming, for example, let me write one frame. Now if any frame, without STP I'm talking, okay, if any frame has been generated by this PC, okay, so
Okay.
it will be forwarded from here. Okay, why it will be forwarded from here, or why it will be forwarded from here, depending on the MAC address table, right? Okay,
Yes.
but if I do not have MAC address table, then I will forward from both, right? Okay,
Yes.
so for example, it is coming from this side, this side, this side, it came here, right?
Okay.
Okay, now see, in the MAC address table of this switch also you will find this computer. Why? Because this computer, if you will say that in this MAC address table, this switch will say that if you want to reach this computer 10.0.0.2, you can pass
Yeah.
via FA0 by 2, right?
Yes.
Okay, and this computer will say that okay, whenever you want to communicate to this, yes, I know where that computer is, and that computer is connected to me via F0 by 2, so it will come here. Okay, and then packet will come here. But Remember, this switch has already informed this switch that I know this computer.
Yes.
Okay, so they will keep on moving and try to communicate. Let me show you with this slide also. Stp process, we have already done that one, but let me explain.
Okay.
Okay, I think in this one you can understand. Okay, now see here what is saying, that if packet is coming here, okay, so switch will say that yes, that computer is connected to me via this switch. Then it will say that no, yes, it's this one, sorry. Okay, so let me come here. Then see, what is the MAC address of this computer? It is 0030.
Mm,
Okay, now
yes.
this 0030 will be the, see, all switches will create MAC table, right? Okay, so it will
Yes.
say that this switch will say that okay, I have one PC connected to me. This is the MAC address and it is connected to me via F0/10.
That's the
Okay, now this PC, this switch will say that yes, I have one MAC address which is traveling in the network, and that MAC address is reachable, okay, via F0/1. Yes, of course, that somebody will come. Okay, so this will switch will say that yes, this PC is reachable to via this F0/1, right?
yes.
Okay, now this switch will say that yes, I know one MAC address which is reachable via this one,
At
right?
0 by 1, yes.
0/1. Now see what will be the problem. Okay, now see, first it will come here. Okay,
Yes.
then maybe someone is here, maybe I can say that someone is here. Okay, he will send packet to this switch. This switch will say that yes, I know this MAC address which is connected via F0/1, right? Okay,
Yes.
so it will come here. Okay, now tell me, this switch, right,
Yes.
will say that yes, maybe if this switch is forwarding from this interface, then it's okay, it will come here and it will be forwarded to this PC, right?
Okay.
Okay, now, but if, because that frame is moving continuously, right? So if this
Yes.
packet came to this, right, and it will say that yes, someone is connected to me via F0 by
F0/1.
F0/2, and this is the MAC address. Then it will say that
Yes.
yes, someone is connected to me via F0/1. Then it will come here. Then this will say that yes, someone is connected to me. So this packet will be moving like this in the network. Okay, and
Yes.
it will never stop. And the MAC address table, what we are talking, so that is normal at a, okay. So it is, at least it is constant for 5 minutes, right?
Yes.
Okay, so with this STP broadcast problem, so your STP will be inconsistent, or you can say not STP, you can say MAC address table will be inconsistent. It will
Yes.
not be stable. So sometime you will find some other information, sometime you will find other information, right?
Yeah. To keep on changing.
Yes, keep on changing. Okay, okay. So that's why your STP is blocking one interface. So your packet is coming towards to switch 2, and then your packet is reaching to destination. That's it. So your packet is not again coming back to that switch 1.
Okay.
Okay. So STP provide redundant network design. Means if you have redundant network, if you have multiple paths towards to another switch, so STP will provide you loop free network. Okay, a good network design provides redundancy in device and network links, right? So if you're talking
Yes.
about good network, right, so good network is what, with redundant links, with active and passive servers, active and passive switch, okay, primary switch, secondary switch, right? When we are talking
Yes,
about
but
redundancy, okay, what is the simplest solution? Add a second link between switches to overcome from the network link
network.
failure, means with this, right? If you have a single link failure, so you can add second link to overcome from the network failure, right? So okay,
Yes.
and when you are adding second link, your STP is helping you to provide you loop free network, right? Okay,
Okay.
but in case of broadcasting, if you're talking about some kind of problems, so such topology will create loops problem if I'm talking about without STP. Okay, now also there is the instability in your MAC address table, or it will be inconsistent MAC address table, as there is no TTL concept working with layer 2 packets or frames. The packet continue to loop around the topology until the links become saturated and the switch is
Which is
forced to
false.
drop the packet, or maybe you can say it will hang after some time because your CPU utilization will be keep on going on. Like see, only two PC has generated the packets, then you saw that problem, right? Okay, only two
Yes.
computers. But if you will see that, okay, like suppose this computer came, this computer generated one packet to this one. Now again one pack, this computer will generate packet for this one, again this computer, or maybe I'm just taking two computer example, but if you have five
Yes.
six computer in the network, okay, and now see
It's gonna
how many
be.
packet, okay, see how many packets is moving in the network, and that packet will be keep on moving, it is not that it will complete after some time. Okay, so these
Okay.
problems can be stopped with the help of STP protocol, right?
Yes. Yes.
Yes. So you can say here the switch CPU utilization will increase, okay, and it will consume all the memory of your switch, and
Then
with that it could crash, or
yes.
maybe your switch can hang, or it can restart, okay, like that. So problem with the redundancy means if you have redundant topology, okay, okay, it eliminates single point of failure. Okay, so
Okay.
this is, you can say that, okay, we have redundant link to eliminate the single point of failure, means when you have single point of connectivity towards another switch, then you came with
Yeah.
one redundant link. But
Okay.
redundant topology can cause broadcast storm, right? Multiple frame copies towards your network, MAC address table inconsistency. Okay, so it will be inconsistent MAC address table in your network, there will be instability problem will be there in your network. Okay, there will be loops problems. So we have understood much about STP, right? Okay,
Yes.
so these problems where can be resolved with the help of STP.
Stp.
Now, so what is loop in the network? It is a phenomenon when a packet is neither arrived to its destination nor it get dropped along the path. Why? Because there is no TTL value, so packet will keep on going on. It keep
Yes.
on traveling in the network until it consume all the network resources or bandwidth, you can say, and it will bring the
Yeah.
network down. In
Like
layer
we
3,
saw last time.
yes, in layer 3 forwarding, we have the TTL value to prevent loops. Okay, but in layer
Okay.
2 forwarding there is no any kind of uh, stopping value, or you can say TTL value. Okay,
Okay.
but if you are talking about layer 3, yes, layer 3 has TTL value, so layer 3 packets will stop after some certain time or after
Okay.
certain destination. Okay, how long sorry, how loop occurs in the network switches, that I have already gave you the example. Like see, when the switches are connected to each other in a linear way, linear way means it's a single path, right? Okay,
Yes.
there is no concern of loop formation because frame has only one path to reach to source to destination in the switching network. So if this PC wants to communicate to this one, no problem, it will come here, it will come here, and it will come and it will communicate, right?
Okay.
Okay. Now, but when switch network use redundancy, STP used to prevent layer 2 loops like C. So if you have this redundant path, okay, so if this PC wants to communicate, so see, it will come here. Okay, now see, it's a single path. You'll see that it has a multiple links, but see, it is a single path. It will come here. Okay, see, it cannot come from this way because it's blocked, right?
Yeah.
Okay, now if you're talking about this way, okay,
Yeah,
but
it's a
this way is
little
blocked. Okay,
block too.
yes, so it has to communicate from this way. Okay. Can you see it's a
Okay.
single path?
Yes.
Yes. So this is the benefit of STP. STP will provide you redundancy, loop free redundancy. Understood?
Okay.
Yes. Now, but when switches are connected to each other in a ring so that we could have backup redundancy, okay, redundant link, there will be exist multiple paths to reach to from source to destination. So why
Yes.
when we connect some kind of ring topology, okay, this is what this is ring, okay,
Yeah, this ring.
this is ring, okay, okay. Now it will create loops in the switching network. So switches connected in the ring for redundancy, bad cabling, okay, a cable in the two ports of the same switch. Like suppose if I will, what I will do, maybe these type of loops will be there in the network as well. Suppose I will take maybe see, sometime you will see some engineer what they do, they take this switch, okay, and now what they will do, see here I can here you will get error. See, they take same cable, okay, and they connect
Okay.
to this same switch. Are you understanding?
Yeah.
Use okay.
It's
So
like a self connection.
yes, same connection. So some people do that one also by mistake. Okay.
Okay.
So in that condition also you will have loops.
Okay.
Okay. So here is talking about that one, bad cabling, or uh, the two port is connected in the same switch with the same
Then switch.
cables.
Okay.
So in that condition you can have loops. Okay.
And this one is a big mistake.
Yes. Yes. So if I'm talking about loop scenario, okay. So loop scenario one. So if your maybe your switches can be connected through this kind of topology, okay, so here loop will be stopped due to STP, no loops.
Yes.
If you're talking, okay, let me connect with the second scenario like this, okay, here also STP has blocked this connection to stop loops.
Yes.
If I'm talking about this third scenario, in this if you will say, okay, let me make it complex. So if you're connecting this also, okay, so this is your root switch, okay, the main switch of your network. Okay, now
Yes.
all the ports of this root switch will be in forwarding states,
What?
but now see,
Yeah.
this one port is blocked here. Okay, here you will see one port is blocked, here you will see one port is blocked. Okay, now here you will see that both port is blocked. Okay, but now you say that, okay,
Yes.
how it will communicate, because see, each and every computers whenever they will try to communicate, they have to pass via root switch to communicate. if
Yes.
if it is not that you and me are directly connected, so we can communicate, why we could go from the root switch.
Roots.
Okay, because if you'll take the path, so this path is very long, right?
Yes.
Yes, but it is, root switch is always working in your network as a transit point. So every packet must pass via root switch to communicate to another computer in the network. Okay, now we have already came to know that it's a broadcast stream, okay, without STP. We have already seen that, right? So if there will be no
Yes.
STP in our network, so see, you can see how many packets will be there in the network. Okay, and see here
Yeah.
I did not created this link as a trunk, but if you'll create this link as a trunk, and if you have, see, right now I did not created this link as a trunk because we have same networks, right? But
Yes.
why we should create links as a trunk link when you have multiple VLANs. See 17. Okay, this is different. Okay, so if you have maybe different subnets, or when you have multiple VLANs, okay, so in that condition you need to create this link as a trunk. Okay,
Okay.
if you will create trunk, and if there will be no STP, okay, in that also you can have multiple frames
Okay.
moving in your network. Okay, switch default behavior, as we know that a broadcast strom frame, okay, will be created first time from the switch, right? Whenever switch will try to communicate from
Yes.
source to destination, so first of all it will generate one broadcast packet, okay, and that broadcast frame will be forwarded to the broadcast MAC address, which is FF, this one, right?
Yes.
Okay, and if we are talking about broadcast strom, we are okay, so in the broadcast it will circulates in your network endlessly, means that it will never end. Okay, and it will keep on moving in your layer 2 topology. Okay,
Yes.
because we have already came to know that because the frame does not have TTL field. Okay, and it also increase the switch CPU utilization. Okay, so now if we are talking about function of STP, STP has one simple functions. Okay, and this simple function you will find in all the switches. Okay,
Okay.
the port, this STP will put the ports in the blocking or forwarding states. So
Okay.
by default, if there is no STP, means all the ports will be in forwarding state, right?
Yes.
Okay, but when you have STP, so STP will either block
Block
or forward.
forward.
Okay, in case there are multiple links to the same destination, okay, it blocks some ports based on the network topology, so that no more than one path exists to reach to the destination. See, when you will have loops, when you have multiple paths to destinations, right? But STP,
Yes.
you have multiple paths, but STP has already blocked those paths with the help of blocking
Yes.
process, right?
Yes.
So there is no loops. STP blocks enough ports so that there is no loops in the network. There is no loss of connectivity. Okay.
Yes.
Now STP convergence, as we know, a switch takes some time to bring its port up. We already know some. Okay, we will come to know about
Yes.
those process: listening, learning, forwarding, disable, blocking, and all. Okay. Okay. Now this process or behavior of the switch is defined by the term STP convergence. Means this,
Okay.
your switch is taking some time to come up, so those is known as STP convergence. It means STP takes a certain amount of time to understand the complete network topology, to decide which port to be put in blocking and which port to be put in the forwarding state, right? Okay, now this is known as STP convergence time. Okay, so this process has been taken. The process is STP convergence, but that the time what they have taken to decide whether this port will be in a blocking state or forwarding state, okay, that is known as convergence time.
Okay.
Okay, so normally this time is
Um,
typically from
okay.
like it will be from 30 to 50 seconds, but we normally, if your switch is new and your topology is new, so at that time it
Okay.
will take 30 seconds, but your topology is old, okay, then it will take 50 seconds, but we'll see in which condition it will take 30 and in which condition it will take 50. Okay, now working with STP, so STP works by selecting one of the switches as the main switch. Because see, if you have
Yes.
multiple switches in the network, so first by default STP will select one switch as a main switch, and that is known as
Yes.
root switch or root
Switches.
bridge. Okay.
Yes.
So what happened as the result, that now all of the frames, means all of the frames of your network will
Yes.
pass only through that root bridge. Okay.
Okay.
If this PC wants to communicate to someone, it will always pass from this one, always pass via root switch, because there is no link, because that link is blocked. Okay. And always try to make root switch like the heaviest switch of your network. Okay. And we'll see that how to make manual. See, by default it is uh, STP has selected this as a root switch, but there is a manual process, you know that one, right? Okay.
Yes.
Spanning tree. Now all the redundant backup path will be kept in the blocking state, so that there will be only one path to reach from source to
From
destination
source
for
to
communication.
destination.
Hence there will be no loops.
Okay.
Okay. What is the use of root switch? The root switch serves as the central reference point for the STP topology. It exchanges the topology information with other switches in the spanning tree implementation in order to notify all other switches in the network when the topology change is required. Now, see, if there is any kind of change, it will notify all the switches. See, that's why we need root switch. These are the behavior and the benefit of the root switch. Okay. First, let's come to know again, because this is important. Okay.
Okay.
See, first process is root switch serves as the central reference point for your STP topology or your STP network. Means if anyone wants to communicate, it will pass only via root switch. There is no
Okay.
other path except root switch. If you are using one link or 10 links, no problem, but it will only communicate via root switch. It exchanges topology information with other switches in the spanning tree implementation. Okay. So who is responsible for exchanging the topology information? Means, see, I means like this is your switch. Okay. Your switch is directly connected to switch, but after root switch, you can have multiple switches and network is very large, right? Okay.
Yes.
But this root switch have the information about these topology. Even some the network is very large from after this switch also, but these all network topology information will be there in the root switch.
Okay.
Okay. And it will exchange with you. Root switch will let you know that how topology is connected and how you can reach from source to destination in order to notify all other switches if there is changes in the network. If you're going to add a new switch, or if you're going to remove a switch from the network, root switch will come to know and root switch will inform you. Okay. This prevents loop and provide a measure of defense against the link failure. If there is any link failure, maybe if this link is down or maybe if this link is down, so root switch will inform you with the help of some kind of BPDU message, okay, that there is a link failure. Okay. And now you can converge and you can communicate with this another link. Okay. It acts as a central point of your network. Okay. It is a transit point, means any type of communication you want, you have to pass via root switch, that is known as your transit point. Okay. Now when we are talking about STP process. Okay. So whenever STP process is running, STP process defines some kind of your port roles
Yes.
and status in the following modes. Okay. So what will be the role and what will be the status of that port? Okay.
Okay.
Okay. Okay, so here STP will define some kind of roles for the switch, roles for the
Yes.
ports, and STP will define some kind of status for the ports.
Okay.
So here we have two options: STP port roles, okay, and STP port status.
First status.
Okay, so in that port roles you have designated port, root port, alternate
Oh,
port. Okay, and status will be only two: whether your port will forward the data or whether your port will be blocked.
okay.
Okay, so whenever you will have these type of network, right? Okay,
Yes.
so let's come with this switch. Okay, let's use layer 3 switch, so we will have multiple options. Okay, okay. So when you have these type of network with the redundant link, right?
Yes.
So automatically STP will define some kind of functions for the root for the switches.
Yes.
Okay, so if you're coming to this
Yes.
switch 1, enable so spanning tree. Okay, so you can see that this
It's a breast.
bridge is a root, right?
Good. Yeah.
Okay, so we'll come to know about the details that why this switch is root switch. Okay, we can
Okay.
see here this is a root switch. Okay. Now by default root switch, all ports will be in the designated
Designate.
designated port and designated port. Designated port means the forwarding state.
Yes.
Designated. Okay, now non-root switch. Okay,
Yes.
non-root switch will find that whether this port will be root port
Yes.
or
What?
designated port, root port
Designated. Yes.
or designated port. Okay,
Yes.
now so maybe this port can be as a root port, okay, or maybe this port can be a root port. But how this switch is going to define whether this port is a root port or this port is a root port? Okay, so see, if you are coming to this switch, okay, now if you are coming to CLI and if you are typing this command,
Yeah.
so spanning tree, see, if I want to reach to root, okay, what is the cost?
19.
19. Okay, now so if I'm talking about this cost, why cost is 19? Because I'm using fast ethernet, right? Fast ethernet is 19.
Okay.
Ethernet is
Yes.
ethernet is what?
64.
No, ethernet is 100. Fast ethernet
100.
is
Okay.
19 and gig interface is 4. See, let me
Okay.
write it.
4.
Yes, see, ethernet, which is 10 mbps, right?
Okay.
Mbps, the cost for ethernet is 100. Okay,
Okay.
for fast ethernet, which is 100 mbps, right?
Okay.
The cost is 19. And for giga ethernet, which is 1 gbps or 1000 mbps, right?
Yes.
The
Right.
cost is 4. We have the list of this.
Yes.
Okay, so here is 19. Okay, and here also you have 19. Okay, so whenever your switch wants to reach to this destination,
Yes.
okay, so whenever your this switch wants to reach root, right? So which
Yes.
port can reach to root switch with the lowest cost? Okay,
Okay.
okay, so this is what this 100 what we are writing, this is cost.
Okay.
Okay, and now you know what is cost, or you forget what is cost? Cost is what is a
No.
metric calculation.
Yes. Calculation of metric. Yeah.
Yes, so switch use cost. Okay, so this is cost. Okay, so which one is costly? Okay, so if
Yes.
understand, just like suppose I'm buying something. So if I want to buy
Yes.
something, okay, from this
Yes.
is a 19, okay, and from this is a 38. So this is lowest one, right? Okay, so
Yes.
I'll make this
Maximum
as a root port.
root of.
Okay, except root port. Okay,
Okay.
your port can be DP or BL blocking. Okay,
Yeah.
or
Okay.
alternate you can say.
Okay.
But here we are just saying as a DP, but I'll tell you whether it will be DP or block. Okay,
But
same here. Come
all
again.
the port that all the port that are connected to the root switch are root port, right?
No, no, no. If this link is, if this cost is 4,
Yes.
okay, now tell me which one will be root port?
Uh,
This one,
this
because
one,
if you will
the
calculate
fourth,
from
yeah, the
this
fourth
this
one,
side it is 8, and from this side
8
it is
and the
19, right?
okay, okay,
Okay, if you want I will show
yes,
you just now, just remind me.
okay,
Okay, okay,
okay,
now so here we are using 19 in the first example, and here we are using 19. Okay, so
okay,
this is DP, and here it will be block BLK, and this is root port. Okay, let's verify.
yes.
Come to root switch. Root switch all port will be in a forwarding state, and the role
Oh,
is designated, right? DP, designated
yes,
port. Close this, come to this switch. Okay, this switch has two port. One is fast ethernet 0 by 1, which is root. Fast ethernet 0 by 1, this is root. And fast ethernet 0 by 2, this is designated port, DP here, right?
yes,
Okay,
yes,
now if I'm coming to this switch, so spanning tree, now see 0 by 1 is root, but 0 by
root,
2 is alternate block. Okay, block.
yes,
So status is block, but the role is alternate. Alternate means
yes,
temporary blocking.
yes, temporary,
Okay, now you see here 0 by 2 is temporary blocking, and this is, but you can say that, sir,
yes,
why not, why this port is not blocked, why this port is not blocked and this is designated, why not like this? Okay,
yes,
because as you say that the from this side you said, okay, from to reaching is 19. Okay, I understood. For root port is
yes,
okay. From this side to reach root cost is 19, that's why this is
yes,
nearest one, so you say, okay, I understood. But what about DP, and why, what is this block? Okay, now see, after root port, okay,
okay,
your all port will become DP. Okay,
okay,
your remaining ports will become DP. Okay,
okay,
now DP and RP, can you see here in this situation? DP and RP,
yes,
okay, DP and RP can be working together. Okay.
Yes.
See what is the condition. Let me write. DP can work with RP. Okay.
Okay.
DP. Okay, sorry. RP cannot work with RP, means direct RP and RP cannot be there, means
Yes.
this cannot be RP. Okay, this port, for
Exactly.
example, this port cannot be RP and this port cannot be RP, like this. Okay,
Okay.
you will never see like this. Okay, now
Okay.
in the third condition is saying that DP, okay, cannot work, you can say it cannot work directly with DP.
GP.
Okay, so one has to stop as a blocking. Okay,
Okay.
so you can say that DP can work with RP and or DP can work with alternate block. Okay,
Okay.
now you can say that, okay, but who will become block? See, by default my port is also DP and your port is DP, but your port
Yes.
came in forwarding but my port came in blocking. But what is the condition? Condition is to becoming designated port. So root switch, all port will be designated. Okay, whether it has
Okay.
2 or 5, 10 port, no problem.
Okay.
Remaining non-root switches, okay, remaining non-root switches, ports, ports towards root with the lowest
Okay.
cost will become root port. Okay,
Okay.
with, okay, root port. Now remaining ports will become DP. Okay,
Okay.
remaining port, whether it is 5, 6, 7, 8, no problem, all ports will become DP. But the problem
Okay.
will come, DP here is also DP and here is also DP. I told you DP cannot work with DP, right?
Yes.
So one port has to become block, but who will block? Whether switch 1, so this is what, this you can say, this is switch 1, this is switch 2, and this is switch 3, right?
Yes.
This is switch 1, this is switch 2, and this is switch 3. But here it will say that whoever have the lowest MAC address, okay,
Yes.
so lowest MAC address, so you will say, okay, let's find who have lowest MAC address between this RP. Type here show version. You can get the MAC address from here also. Okay, or you can write this command, so spanning tree, you can get your MAC address from here also. Okay,
Okay.
so let me copy this MAC address for this switch. So for him the MAC address is this one. Okay, let me come to this switch CLI, the MAC address is this one.
Yes.
Copy, close. Now if you come here to this, okay, now tell me, okay, in this, uh, which one is the lowest MAC address? Count from this one. 00500060.
6. So
So
S2 is the lowest
yeah,
one.
so this is the lowest one. So this switch will
Mm.
win and he will say that yes, my MAC address is lower than you, so my
Okay.
port which is towards your DP, okay,
Okay.
so my ports towards your DP is winner. So this is winner, right? Okay,
Okay. So this is the first condition.
yes, first condition.
Okay.
Okay, so when this is winner, okay, so your DP is loser, so when your DP is loser it will become
Block.
block. Okay, now,
Okay.
so by default all ports of the root switches is the designated
Designated
mode and status is always
forward.
forward. As per STP summary, spanning tree protocol is necessary in layer 2 networks to prevent the logical loops. Okay, and you know that STP is automated automated process, right? It's automatic process. We don't see, if you are talking about
We don't
configuration,
configure
did we configure anything in STP? We are just talking about STP.
nothing. Yes.
Okay, we are just talking about STP. Okay, so now here network administrator have options to change the STP process and behavior according to
Okay.
its own topology, right?
Yes.
But by default STP is running with the default process.
True.
STP has some types like STP what we are talking. Okay, so it the standard is 802.1d.
Well,
Okay, now after STP, the so these are known as STP enhancement.
okay.
Okay, per VLAN STP. Okay, now PVST plus means per VLAN spanning tree protocol plus means some advanced features. Okay,
Okay.
now so then after we came with RSTP, rapid spanning tree protocol, then MSTP came.
Okay.
Okay, but we'll come to know which STP we are using nowadays.
Okay.
So before STP, okay,
Okay.
it was STP, but the name was common spanning tree. Common spanning tree means common spanning tree utilize a single STP instance for all VLANs. Means if you are using one VLAN, 5 VLAN, 10 VLAN, there will be single STP for each and every VLANs.
Okay.
Okay. Now, but if we are using this PVST or PVST plus, so PVST use separate STP instance for each VLANs.
Okay.
Okay, and now if we are using this scenario, when we will use this scenario, you will come to know each and everything. See, let me come with
Okay.
this. So let me take one switch here. Switch 1, switch 2, switch 3. Cable you can use. Okay, so this is our root switch. You can keep it here. Switch 2, switch 3. So we can say here this is our
Okay. Sweet.
root switch. Okay, this is our switch 1. This is our switch 2. This is our switch 3. Okay, this is the default behavior. I did not configure anything, right?
Yes.
Okay, now if I'm coming to root switch, come here to root switch, enable. So spanning tree. Okay, so this switch, this is the root switch. Okay, all ports are in
Yes.
designated port. Okay, forwarding states. Now what I'm doing, I'm going to create some VLAN. So I'll say here I'm going to create
Okay.
VLAN 10. Then I will say VLAN 20. Okay, on switch 1 and exit. And now if you're typing here, so a spanning tree.
Okay.
So a spanning tree. Can you see here? You have VLAN 1 only, right?
Yes.
Okay, no problem. But you created VLAN 10 and 20. Now you come here,
Okay.
CLI, enable,
Better change the first name too.
No problem, we'll change it.
Okay.
VLAN 10, VLAN 20. Okay,
Mhm.
exit. Okay, let's change host name as switch 2.
Yes.
Come here, I'll say that conf t host name switch 1, and here we'll come and say that host name switch 3. Enable conf t VLAN 10, VLAN 20.
Yes.
Okay, v okay, just for now let's exit, and then conf t host name is switch 3.
Yes.
Okay, now if I'm coming to switch 1, and if you're typing here, so spanning tree. Okay, so right now you are saying that only VLAN 1 is running, right? Okay,
Yes.
and now if you are saying here, so interface trunk, no trunk interface, right? But as per our
Yes.
topology, when you have multiple VLANs, okay, so you need trunk link, right?
Yes.
Okay, so let's come here to create trunk link. So come to this switch, conf t interface range f0/1-2 switch port. I think encapsulation is default in trunk, in encapsulation is default. Okay, so switch port mode trunk. See, this is just a layer 2 switch. Okay, but layer 2 switch trunk
Yes.
encapsulation is default. Okay, but in layer 3 switch you have to define encapsulation in packet tracer. Okay,
Yes. Yes.
and in I think in the real also layer 2 Cisco is ISL is default, but if you can change, if you can define it.
Okay.
Okay, so this is configured, trunk is up, no problem. We can come to this switch also, conf t interface range fa0/1
One,
dash
two,
2 switch port mode trunk. Okay, fine, and this we can come here, conf t interface range f0/1/2 switch port mode
uh,
trunk. Just wait. Okay, and now if you're coming to switch 1,
yes.
so spanning tree. Now see, after enabling trunk, okay,
Yes.
now see, you have VLAN 1 default. Okay,
Yes.
so for VLAN 1 STP is running.
Yes.
Okay, now see, for VLAN 10 STP is running. Okay,
Yes.
but this one, this per VLAN STP, okay,
Okay.
per VLAN STP has been enabled when you enable
The trunk link.
trunk link. Okay, remember in the first time here we have already created those things, right? But when we created trunk link, after that for VLAN STP started working, right?
Okay. Yes.
Okay, so here also if you will come, See, for VLAN 10 STP is running, and now if you'll come enter, for VLAN 20 STP is running. Okay.
Okay. So before we cannot see
No,
the VLAN 10 and
no,
20.
no, no. Now see, if right now, we have VLAN 10, VLAN 20.
Okay.
Okay, now tell me for VLAN 10 and 20, which switch is root switch? For VLAN 10 and 20, which switch is root switch? This switch, because for VLAN,
The first one.
yeah, because
Yeah.
as we are talking about per VLAN, so for VLAN 10
Yeah.
also STP is running. Okay, so
Yes.
when it STP will run, so it will define root. Okay,
Yes.
for VLAN 20 STP is running, so it will also
Yeah.
define root. Okay,
Okay.
so for 10 and 20,
Okay.
switch 1 is root, right?
Yes.
Okay, now if I'm coming here to switch 3, right, and if I'm
Yes.
trying here, so spanning tree, now see here,
Yes.
VLAN 1, this is, see, you have two type of information. This is for your root switch information, and this is your information, right?
Yes.
Okay,
Yes.
so this is means for VLAN 1 I am not root. Who is root?
Yeah.
This guy 007, this is the root. Okay, what
Yes.
about VLAN 10? VLAN 10 also I am not root, someone else is root. Okay, now what
Yes.
about VLAN 20? Same information, I am not root, someone else is root, because see, my this is my MAC address and this is the root MAC
Yes.
address, right? Okay,
Yes.
but if I will say that no problem, I am going to create some VLAN 30. Okay, name IT, which is my own VLAN. Okay, that is switch 3 own personal VLAN. Okay, and now if you are saying so spanning tree, now see, for 1 you can see someone else is root, right?
Yes.
For 10 someone else is root. Okay,
Yes.
20 switch 1 is root, but what about 30?
Yes.
Now see, can you see here, for 30 wheel STP is running, right?
Yes.
Okay, but who is root?
I'm the root. So this
Okay,
switch is the root one.
yes, no, switch 3, see, now port is what?
Yes.
Do you think that port is blocked?
No, the port is not blocked.
No block. But you say, sir, how if port is not blocked? You said the port is blocked. Now see, whenever your switch will try to run this, okay, okay, now see, whenever your switch, this switch 3, we are talking about switch 3, right? Whenever your
Yes.
switch will try to send any information towards this link, which is block, right?
Yes. Yes.
In VLAN 1,
Okay.
understand, this is very important. Okay,
Okay.
okay, now see, switch 3, whenever switch 3 want to send any information via this link inside VLAN
Yes.
1, this is block,
Okay.
right?
Yes, it is blocked.
Yes, which one? This link is blocked, this link is blocked.
Yes.
Okay,
Yes.
okay, now if I'm coming here, okay, now VLAN 1. Now again come to VLAN 10.
Okay.
Whenever your switch 3 want to send any information inside VLAN 10 via this port is blocked. Why?
Okay.
Because it is blocked due to some kind of STP which is running through root switch, right?
Yes.
Okay, same condition for 20 also, it is blocked, right?
Yes, it's blocked.
Now, but for 30 is saying that I am root. Okay, because there
Okay.
is no 30 in the network. Okay, but for
Yes.
30 I am root, so all ports will be acting as a
Forwarding.
forwarding and designated. So for 30 I
Yes.
am boss. But for 10 and 20 I'm
Yes.
not boss.
Yes.
Okay, now if right now you are boss, right? Because
Yes.
there is no 30. So when this VLAN 30 is sending some kind of STP information inside VLAN 30, inside VLAN 30 when STP is running, so inside VLAN 30 how many how many switches is running VLAN 30? Only
Only
one.
the switch.
So when this
Yes.
STP is trying to compare with this MAC address, so there is no one to compare. So if no one is compared, so I am the boss.
Yes.
Okay, but if it you will come to switch 1 and come here conf t VLAN 30
Okay.
exit. Okay, switch 1 is also created, and if you came here enable conf t, okay, and now if you'll say that VLAN
We
30
don't.
exit. Okay, and now when you have someone to compare, right? So now I'm not
Yeah.
boss. So when I'm not boss, so I have to run according to STP process, and according to STP
Yes.
process this port is blocked. And now if you'll see that who is boss now, so if you'll see that, so a spanning tree. So for 1 this switch is root, for 10 this switch is root, for 20 this switch is root, and for 30 also
Yes.
this switch become root due to its lowest MAC address. Okay,
Yes.
so this is the per VLAN. So right now we are not using STP in the switches, we are using PVST and
Yes.
PVST plus.
Okay.
Okay, now if you say that, sir, where we are using PVST, not PVST plus. So if you'll say that, so version, what is the version of this switch? 12.2, right?
Two.
Okay, but if I'm coming here, let me start this switches. So spanning tree. Okay, so this switch is root. Okay, fine. And what is running here?
Sonic three.
No, a spanning tree is there, but
Yes. The version of that switch.
PVST plus is running. But let me, I think we can make, when we will make, what you can say, trunk link or something like that. At that time it will come, no problem. Conf t VLAN 10, VLAN 20, exit, and then interface range. Interface information is not there, so bring the interface E01, E01. Okay,
Yes.
E0/0-1 switch port trunk
Trunk.
encapsulation dot one q, then switch port
Yes.
mode trunk.
Trunk.
Now come here conf t VLAN 10, VLAN 20, exit interface range E0/0-1 switch port trunk encapsulation dot one q, switch port mode trunk. And now if we are coming to switch 1, so spanning tree. Okay, now this is running.
Okay.
Okay, but I think I have seen somewhere PVST plus. See it, just a moment.
Okay.
Okay, so now let's come to your GNS. See, whenever you want to verify that,
Yes.
if see, as I told you that right now we are not using STP, we are using
Yes.
per VLAN STP, PVST
Yeah.
and
Yes.
PVST plus. But these PVST and PVST plus is will depend on your version of your iOS,
Okay.
Cisco iOS. So if I'm typing
Okay.
here, so spanning tree, okay. So here you will know that okay, you have multiple instance of STP depending upon your
Yes.
VLAN. So if you have 10 VLAN,
Yeah.
you will have 10 STP. Okay.
Okay.
And if you want to know which version I'm using, see here you are not getting okay which STP you are using, whether it is PVST or PVST plus. So you can type here, so a spanning tree summary,
Some.
enter.
Okay.
So you can see here switch is in PVST mode, and how many,
Okay.
so this switch is root 4 VLAN 1, VLAN 10, VLAN 20.
20.
Okay, with this command you will know. But if I am coming to this switch, and here I will say that conf t VLAN 50 exit. Okay, and if I'm typing here, so spanning tree
Spanning tree.
summary. Okay, so see here it is saying that okay, first try, let me do so spanning tree before summary. So see, for how many VLAN you have, VLAN 1, VLAN, see, in this switch, see that,
Yes.
so VLAN brief. So you have VLAN 1, VLAN 10, VLAN 20, VLAN 50, right? So you have 4 VLANs,
Yes.
right? Okay,
Yes.
and now if you're typing here, so spanning tree. Okay, see, for VLAN 1, I'm not root, someone else is root, right?
Yes.
Okay, for VLAN 10, for VLAN 10, someone else is root. This is my MAC address,
Yeah.
okay?
Yes.
200. This is my MAC address of this switch 2, you can say. And now, if I'm coming to VLAN 20, I'm not root. For VLAN
Yes.
50, for VLAN 50, see,
Yes.
I'm root.
Yes.
And if you are writing here, so spanning tree summary, now you can say that
Yes.
you are running per VLAN STP, root bridge,
Yes.
you are root for VLAN 50.
Yes.
Okay, and these are some other things we will come to know. Okay, port fast,
Plus.
BPDU guard, loop guard, and all those things. Okay, uplink fast, backbone fast. Okay,
Okay.
and see, can you see this these options? Okay,
Okay.
uh, blocking, listening, learning, forwarding, like that, those kind of things. Okay,
Yeah.
so these things we'll come to know when we learn some advanced. Okay, okay.
Okay.
So now we came to know that right now we are not using STP, we are using PVST, and we will see that we are using PVST plus also. Okay, so
Okay.
PVST plus is known as per VLAN spanning tree plus. Okay, so you can say here first if you are talking about CST, common STP. Okay, common STP protocol utilize a single STP instance for all VLANs. Okay, see, by default, if you are not using trunk link, so by default what, by default your STP is running CST, common
Okay.
spanning tree, but when you will enable trunking,
Trunk.
at that time you will enable PVST.
Okay. Yes.
Okay, and in some time refers to mono spanning tree, so sometime people used to call it as a mono spanning tree. Okay,
Okay.
all CST BPDU are sent over the native VLAN on a trunk port, and though they are untagged. So
Okay.
when you are using single VLAN, right?
Okay.
So of course, what is that use of tagging then? Are you understanding? When you
I
need
see.
tagging, when you have multiple VLANs.
Yes.
Okay. Now PVST plus, PVST employs a separate STP instance for each VLAN, improving the flexibility and performance of the switch. PVST requires trunk port to use ISL encapsulation. Okay,
Okay.
ISL or dot.
Oh,
Okay,
that one.
maybe. Okay, we'll see that one because we have used dot one q. Okay, I can ISL, or you can say simply encapsulation. Okay,
Yes.
PVST and CST are not compatible together. Okay, but when we are using PVST plus, so if you have any older switches in the network which support CST, okay,
Yes.
then it
Okay.
you can communicate with PVST plus, but CST cannot communicate to PVST, but CST can communicate to PVST plus. Okay, so
Okay.
PVST plus use both encapsulation ISL and
That
dot,
one cube.
dot one cube. Okay, we will verify this one. Here is saying that
Okay.
PVST is using only ISL encapsulation. Okay, and
Yes.
PVST plus is using ISL and 802.1q, but here we have used uh, so interface trunk. Here we are using, okay,
That
maybe
one cube.
it will be related to negotiation because we made it
Only
manually,
this
right?
is? Yes, I think so.
Okay, maybe we'll check with the negotiation. Okay,
Okay.
well, later we will check that. Okay, so STP has continued to evolve over time, means slowly the changes came in the STP. Okay,
Yeah.
so there are some other modern STP is like RSTP and
Yes.
MSTP, means rapid spanning tree protocol and multiple
Multiple
spanning
spanning tree.
tree. Okay, so this, okay, with this we came to know about PVST, right?
Yeah, plus.
Okay, so see here, for VLAN 1, VLAN 10, this is root, VLAN 20, this is root, but for VLAN 30, who is root?
The
Switch
S
switch 3 was
switch.
root, right?
Yes.
Okay, so here we have some kind of information that regarding a spanning tree protocol. Okay, so legacy STP was like what you can say, it's CST, common spanning tree. Okay,
Okay.
so PVST is also legacy, but the PVST plus, you can say, for nowadays it is legacy. The new is RSTP, what you can say, RS, like rapid spanning tree. Okay, like you can say, yeah,
RPSP.
like rapid per VLAN STP.
Okay.
Okay, and MST is the newest. Okay, so most of
Okay.
the company they use MST, not if they are configuring and if they are using large switching network. Okay,
Okay.
then they use, if they are configuring, then they configure MST, but if they are keeping as a default, so they are just using per VLAN STP.
Good.
Okay, and you can say these are the improvement of the STP, means
The
okay,
SCP.
who created STP and who created these things. See, PVST has
RPSP.
been created by Cisco, PVST plus has been created by Cisco. Okay,
Okay.
RSTP is what? RSTP is rapid spanning tree, which is open standard, which will be supported on all other type of switches. But if we are
Okay.
talking about rapid spanning tree per VLAN STP, which is supported by Cisco switches only. Okay, see, this is IEEE, which is open standard. Okay,
Good
see,
standard.
rapid spanning tree is open standard. Okay,
Yes.
MST is multi spanning tree is open standard.
Okay. From
But
the
these are what? These are Cisco vendors. Okay, Cisco
property.
propriety, you can say. Okay, so these are some STP introduction in brief, that how STP is stopping loops. Okay,
Okay.
so these things we have already discussed. No problem. Okay, okay, STP IEEE 802.1q. This is the standard of STP. This is original
Okay.
version of STP 802.1d. This one. 802.1d, which was developed in 1998. Okay,
Okay.
okay, so this is the original standard. After that they started modifying. Okay, provides to
Okay.
supports for one VLAN only. Okay,
Yes.
use as a foundation to understand the STP network. Okay, but no, it is not supported nowadays. Okay,
Okay.
building the STP topology is a multiple convergence process. Yes, STP switches exchange bridge protocol data unit. Okay, so now when we are talking about this bridge protocol data unit and those all of other options. Okay, okay, so these things we can work tomorrow. Okay,
Okay.
because okay, this class is already 1.5 hours. Okay,
Yes.
okay, okay, so from tomorrow we'll come to know about other STP conversions, like how
The DP.
switches is understanding about the messages. Okay, so
Okay.
those messages are sent via BPDU protocol to understand the
Yes.
topology and informations. Okay,
Okay. The exchange BPDU.
yeah, between switches.
Okay.